What is hashing, or what is a hash? This is a term in cybersecurity that I want us to learn today. Join me as we demystify this concept. A hash is a fixed length of string of numbers and letters generated from any data using a mathematical algorithm. So that process of converting is what we call as hashing. So what happens? You input your data, then a hash function takes that data to convert it into a hash output, like A793B85. That is a hash now. So it acts like a digital fingerprint of your data, is unique to that specific data. It has a fixed length. It is one way. One way it means, for instance, if you take mango and you blend it, you get mango juice. You can't take mango juice back into a mango fruit. So that's what we mean by one way. Then one change, it brings a total different hash. That means same hash, same input. Different input, completely different hash. Even if we just add a dot on that file, we'll get a total different hash. Where do we use hash? As used in password storage. It stores secure password without keeping the real password. It is used to maintain file integrity. It is used in digital signatures to verify authenticity of a message and documents. It is used in websites to ensure that the websites are authentic using the certificate and socket SSL or TSSL. Digital forensics to identify files and detect any tampering. So why is it used? We said for security, to keep sensitive data. Integrity. Integrity is one of the three core principles in cybersecurity, that is confidentiality, integrity, and availability. So one way of achieving integrity is by hashing. Then it brings about efficiency because it's quick to compute and to compare these hashes. Then it maintains consistency. Since we gave in the same input, we will always expect the same hash. How is it used? You get your data, you pass it through a hash function, then you get a hash output. You either compare when you are authenticating or you store it. Practicality. During registration process, we are creating an account, and I've seen this implemented, especially in KRA. KRA have done so well in this. So you choose your password. Let's say my password 1234, but don't use this password because I'll break in your system. So you key in your password. The website hashes your password. In this case, using SHA-256 or 512 because those are strong. Then it hashes it. We get a hash. In this case, it's F7, that number. And then that database stores that hash, not the real password. So that when you're trying to log in or verifying your password, you enter in your normal password in plain text, but then the website will hash that plain text into a hash. In this case, this one here. Then it compares with what exists in its database. Is it similar? If it's similar, you are granted access to that site or to that application. But if it's not, you are denied. Using a different example, in file, I create a file and I create a hash for the file. I send it to you. When you receive the file, you also create a hash for the similar file using the similar algorithm. You compare the hashes. If my hash corresponds with yours, it means that file has not been tampered with, it has not been modified, and is authentic as the original file. So that's another way of explaining this. It's that simple. Is it so?